All right, in 7.5 we're going to take a look at matrices. Matrices have a lot of applications, but it's essentially a system of equations. So hold on, let me go to one here. So they're kind of skipping it and jumping right to what they do. Well, I shouldn't necessarily do 0 to z, but so here would be an example. You can turn a system, now this isn't linear, this is three-dimensional here, but you can turn a system of equations like this into a matrices. We're just essentially dropping all the variables off and just putting the leading coefficients to create this matrix. Now, let's get the basics of matrix. So we can do math essentially without the variables showing up. There's lots of applications. There's whole systems of mathematics based off matrices and all their applications. But let's first just get the idea of the basics. So matrices are going to go rows by columns. So if you have a matrix that is a 3, well, this is 3 by 3, so the answer is obvious. But if you had 3 by 4, it would be 3 rows and 4 columns. So here's my matrix here. Again, this is a 3 by 3, which is kind of obvious. You could have got it right even if you didn't understand. 3 rows, 3 columns. Now, if you're looking at particular entries here, the way this works is this is going to be rows first, column second. So row 3, column 1 would be a 3. So what entry is in A22? So that would be row 2. Column 2 would be a 4. Okay, now addition and subtraction are going to work if I'm assuming you've done the complex number part of this already, and so it's going to be the same thing. We're going to be just like you would add the x portion of or the real portion and the imaginary portion of a complex number. We're going to add the corresponding cells of two matrices. So if this is matrix A and this is B and we want to add them together, we're going to add the A cell, the 1, 1 cells together, the 1, 2 cells together, etc. So again, this isn't using real numbers, so it's a little weird, but we're adding these, adding them up. Let's do it with real numbers, it'll make more sense. So we're putting these cells together, just add the matching cells. So 4 and 5 make 9, 3 and 0 make 3, 1 and 9 make 10, 2 and 7. I'm just adding those corresponding cells in each of the matrices. Now it works the same for differences. I'm going to just subtract the corresponding cells. So negative 2 minus 8 is going to be negative 10. 0 minus 5, 3 minus 1, 1 minus 4, and there we go. Okay, so this is just asking us to do both here. So this is a 3 by 3, but nothing has really changed. Same thing, just extended one more column in a row. So we're going to do the corresponding cells there. 8, so 14 and 0, 4 and negative 5. So anyway, just going through here one at a time. It's all written down here, but it's pretty obvious. We're just matching up here and adding. And we can do the same thing with subtracting, matching up, subtracting, matching up, subtracting, matching up, subtracting, all the way through. Okay, so pause it if you want to try this on your own. But if we add these matrices, we're going to get 5, 2, negative 3, 4, 5, 0. Okay, now scalar multiplication. Scalar we're multiplying just by a constant value. And so it's going to be as intuitive as you'd think. We've seen this too with complex numbers. We're sending that, it's like distributing essentially, but we're distributing it to the entire matrices. So it's literally going to be multiplied to every value, every cell in the matrix. So we're going to multiply this by 3. So every value, every cell is going to be multiplied by 3. We create this. Okay, now how about multiplying through by negative 2? Well, this should be matrix B, I suppose, but so we're just going to multiply every cell by negative 2. So I've got negative 8, negative 6, negative 2, negative 4. Okay, Now, just getting more complicated here, we're going to multiply by these scalars and then add them together, but really basic here. I'm just going through 3A, multiplying matrix A by 3 all the way through, I create this. Multiplying B by 2 all the way through, I create this. Now, we're going to add these two together, so 3 and negative 2. 0 and 0. 12 and 0. So they're doing that here, matching it with the corresponding cell, and we get down to here. Okay, that's a real basic introduction to the operations on the matrices. We'll get more complex as we go. Again, there's whole books can be dedicated just to matrices. But the most basic application is we can take a series of equations and linear equations, whether it's 2 or 3-dimensional, and we can extend them into a matrix. We can turn that into where we can work the problems without the variables in front with only the coefficients, and that's where we're headed.